Hey guys, welcome to my channel. My name is Anand. Today I'll be showing you how you can use Spark on cloud. Probably you are using it in your project, probably you are using it on-prem. You might also have installed locally in your laptop. But today's video is more about how you can have a more production-like environment on cloud. But also if you would just want to upskill your AWS knowledge, I think this is going to be a very good tutorial for you. How to get started with AWS EMR. There are other options as well. For example, Azure also offers Spark on cloud. You can use Databricks, you can use Azure Data Factory. There are some good options with GCP, with Oracle, but I'll be focusing just on the AWS part today. So if you need to run any kind of Spark workload on AWS, there are several options. Two of them are AWS EMR and AWS Glue. So I'll be focusing on the EMR part today. If you are not familiar with AWS, if you don't have a free account with AWS, I'll just paste a link over here on the screen for you guys so that you can go back and refer my other video which explains a little more about AWS and how you can start your journey with AWS with a free account. Let's get started here. Once you sign into your AWS console, you will see a bunch of things like welcome to AWS, AWS health, cost and usage, all those sort of things. Probably you won't see recently visited if this is your first time. If you do not worry, you can just use the search toolbar here and you can write EMR and straight away you can navigate to EMR console. So I have EMR console open up in a separate tab. In order to start using EMR, I'll just click on create cluster. Now if you are exploring Spark for the first time, you can just give a cluster name, you can enable logging, probably select EMR 6.3 and above, because I think there has been some fixes done after 6.2.1, which is, for example, one of the issue was log4j, which has been fixed in 6.3.0. so yeah, use 6.3 or above, but you can just select 6.3 and then select Spark. To start with, you don't need a multi-cluster Spark environment. You can just have a one master node. You can specify one. You can select M5X large instance type, or you can learn more about the instance type by going through this link. Since this is just an example, we are good to use a journal instance type. We don't need a compute intensive or a memory intensive instance type. And the last thing which you would need to select is to create your own EC2 key pair. So EC2 key pair would enable you to SSH into your EMR cluster. So imagine it as if your virtual machine is residing somewhere on some rack in AWS region, and you're sitting at home. How would you authenticate yourself that you are the owner of that virtual machine? It's through the EC2 key pair. So if you don't know how to create this, there are some very good tutorials, but feel free to comment down below and I can definitely help you answer your specific questions related to how to generate your EC2 key pair. And then again, you can leave EMR role as a default, EMR default role and EC2 instance profile, everything you can leave it as default. But in this use case, I'll be going into the advanced section because I would like you to know how you can also install other dependencies, how you can select specific applications, how you can specify Bootstrap actions, all those sort of things. And as we progress through this video, I'll show you what all those things exactly means. So I'll click on advanced options. So again, I'll select 6.3 because I believe, if I'm not wrong, there are some fixes done in 6.3. I do not need Hadoop, Hive, Q, Pig for this example. I just need Spark. I would click on Jupyter Enterprise Gateway. I would click on Jupyterhub. I'll explain this why am I selecting Jupyterhub in this case. Now again, if you are just exploring Spark and you don't need any dependency, you can skip this part. about how you can enter some configurations for your Spark. But in this use case, again, I would like you to show how you can specify some of the configurations to Spark in order to tell Spark that there are some dependencies which you need. So I'm going to copy and paste this Spark defaults. So this is my Spark defaults parameters. I'm going to change Spark configurations like serializer, SQL extension, and all those things. So I'll explain this again. What exactly is this? What is this Cairo serializer and all those things? I'll explain this in a bit. And then I can click on next. I can leave network and subnet as is. Again, I just need one Spark node cluster. I don't need a multi-cluster node. So I'm going to select 0 worker nodes but 1 master node. And I can click on next. I'll give a meaningful name to this. So I generally like to follow the naming convention. So dev is for development environment. I can leave the logging as is as of now. This is my logging bucket where all the logs will be written for this EMR. And here the last part is the Bootstrap action. So Bootstrap is nothing but what I'm telling EMR is, before spinning up my EMR cluster, install some dependencies. Probably I have some Python dependencies. I would have probably, if I want to generate maps, I would like to have Folium Python library. If I want Snowflake connectors, I would like to install some jar files in my EMR cluster if I need to connect my EMR with Snowflake and so on. In this example, I'm going to take Apache Sedona as an example. So Apache Sedona is basically a framework which helps you to perform large scale spatial data. So probably you have already worked with GeoPandas before in Python. Sedona, previously known as GeoSpark, is a Spark framework wherein you can, if your data has location related attributes, for example latitude, longitude, or polygons, all those kind of information. So Apache Sedona helps you to process and do those enrichments. If you are interested how to use Apache Sedona, please again do let me know. I can make a separate video how to use this with your data frame and what kind of queries you can write in order to make those kind of enhancements and enrichments in your data. But yeah, for this example again, I want to install some dependencies related to Sedona. So my Bootstrap would be a shell script. Basically I'm installing first of all some of the dependencies, for example pip install Apache Sedona, GeoPandas, GeoJSON. And then for my Spark, I am going to copy some of the jar files, Sedona jar files, GeoTools, all those things into my EMR cluster. So in this example, I have kept some of those jar files inside one of my S3 bucket, which is under EMR jars, and I'm just copying it into my jar Spark jar folder inside my EMR cluster. So this is an like EMR-anand.sh is residing into one of the S3 bucket. So I'll just specify that bucket over here. So configure and add. This is my Sedona dependencies. I'm going to write EMR application. So I'm just giving the path of where my Bootstrap file is. Bootstrap files. sh. No arguments needed. Click on add, next, and again I will give my existing EC2 key pair. If you don't have it, you can create it, or again do let me know if you need some help in order to create one. And that's it. You can click on create cluster. Right now it's starting, so generally it takes 6 to 10 minutes, anything between 6 to 10 minutes in order to spin up, install all the dependencies and go into the waiting state. So I'm gonna pause the video now and see you in 8 to 10 minutes. Okay, so we are back. Our cluster is in the waiting state. Before proceeding, I just wanted to explain one more important thing, which is about security group. So how would we access this cluster? there are two ways as of now. Either we can SSH into our EMR cluster, or we can use Jupyter Notebook. So if you remember, we enabled Jupyterhub and we also enabled Jupyter Enterprise Gateway when we were spinning up this Spark cluster. So two ways, SSH and Jupyter Notebook. We are going to use Jupyter Notebook, but before opening up a Jupyter Notebook interface, we need to enable something. So right now, this Spark cluster, what we have in front of us, is kind of secured. Nobody can access it apart from us as of now. So in order to enable that, we can use Jupyter Notebook from our local machine, because this Google Chrome is on my local machine and this Spark cluster is somewhere sitting on some rack of AWS region, Amazon's region. So in order to do that, we need to enable something on our security group. We need to enable the TCP protocol for the Jupyter Notebook port. I know it sounds complicated a little bit for the very first time, but if you just follow along with me, it's very simple. So if you click on the security group, you'll end up here, and then you have to edit an inbound rule. So this Jupyter Notebook listens on port 9443, so we need to enable it. What you can do is you can just click on edit inbound rules, and then you can select custom TCP protocol. You can specify this particular port range 9443, and you can give your own IP address. So your home network should have an IP address, a public IP address associated to it. So you can just give that IP address. It's very easy to find. You can just write in what is my IP address on Google, and it should give you your IP address straight away. So that you need to follow it over here, and that's it. Once you do it, you can come back to the EMR console. You can go to application user interface. As you can see, we have a Jupyterhub application already started for us. I'll just copy this URL. I'll go here and I'll paste this. And now the default username and password for the EMR inbuilt Jupyter Notebook is Jovian and Jupyter. Again, I'll paste this in the description so it's easy to follow. I'll just click on sign in, and there we go. We have Jupyter Notebook in front of us. And if you are familiar with Jupyter Notebook, if you have been working with any kind of Python development, you would know that you can go to new and have a Python notebook here. But here you will also see Spark and PySpark kernels for us. So if I click on PySpark right now, and let's say I just write Spark, it's starting the Spark application. Cool, so we have a Spark session available. I'm going to write a very simple Spark code, PySpark code. I'm just going to read a sample JSON file which is located in my S3, and I'm going to read it and I'm going to display it. So spark.read JSON. I have to give my S3 path. So here is my S3 path. I'm going to run it. Hopefully it won't fail. Okay, so let me see the schema of my JSON file. Age, car name, and I'm going to just quickly print this data frame. Awesome. So yeah, we have this. The Spark is running fine. Now just to make sure that our jar dependencies, what we installed through Spark defaults and through our Bootstrap action, that's also been registered. So I'm going to just write import Sedona. It found Sedona. Great. I'm going to run this small piece of code here which will validate and verify that our Sedona is successfully registered and it's ready for us to use. Awesome. So yeah, this looks great. This is how you can spin up your own Spark cluster. You can deploy your Spark workloads using AWS EMR. We want to make sure that we terminate it at the very end of it, so do not forget to terminate it. But for now, I think this is good. Let me know if you like the video and if you would like to see something similar, what Sedona can do, how you can connect EMR with Snowflake and all those sort of things. Thanks a lot for watching the video. Hope you like it. Bye bye.